So substitution and elimination should be review from last year. And it is good to know how to do both, but you don't need to do both on each problem. You just need to do one or the other. So looking at the first set of equations, would it be better to do substitution or elimination? That was not an option. So, I would prefer to do elimination because no variable is without a coefficient. Now, it doesn't matter. They'll both work every time. Just sometimes one's easier. So what do I need to times the top by to eliminate the y's? -4. If I times it by 4, I'd have an 8y on top and an 8y on bottom. And in order to cancel, they need to be different signs. So I'll times it by -4. And I get -12x minus 8y equals, what is that, -128? Okay. Now I just add the two equations together and the y's cancel. So I get -19x equals -152. Please tell me 152 is divisible by 19. 8. So I get x equals 8. So these two lines intersect at a single point, and the x value of that intersection is 8. How do I find the y value? Plug it back in. Does it matter where? No. Either equation will work. The top one looks easier to me. So 3 times 8 is 24, plus 2y equals 32. And all I have to do is solve for y. Subtract 24, subtract 24. 2x equals 8, so x equals, or no, sorry, that's a y. 2y equals 8, so y equals 4. So these two lines intersect at 8, 4. And 8, 4 is the only set of numbers that satisfies both equations. The top equation has an infinite number of set coordinates that satisfy it, and so does the bottom, but there's only one set that goes into both of them. Okay, second set of equations. Do I want to do substitution or elimination? It's already set up for elimination. I could do substitution. It would be pretty easy, but it's easier to eliminate. So I get 8x equals -16, so x would be -2. So now I need to plug in -2 to find the y value. So I'm going to plug -2 in there. 3x minus 2y equals -14. Oh, that's the x value. My goodness. How did I ever get a degree? Plug it in there. -6 plus y equals -14. Add 6, add 6. So y equals -8. So the coordinates for that intersection are -2, -8. Okay? For the third one, let's do substitution, just to review how to do it. So the easiest one to isolate is that x without a coefficient. So I'm going to add 2y to the other side, plus 2y. Now I need to substitute -6 plus 2y in for the x value. So I'm going to plug this in here. So -2 times -6 plus 2y plus 4y equals 10. 12 minus 4y plus 4y equals 10. What do you notice? The y's cancel, and I'm left with 12 equals 10, which is no solution. So what do we know about these two lines? They're parallel. Okay? All right. Could I have looked back at the original equation and said, oh, those lines are parallel? Well, if I times the top by -2, I get -2x plus 4y equals 12. And notice that the equations are the same, but the answers are different. And that can't ever happen. If the equations are the same, the answers need to be the same. All right. Fourth one, substitution or elimination. I'm going to do let's do elimination. Substitution would work. What do I need to times the top by? 3 and the bottom by 2. And that will cancel the x's. Hey, shh. So 3 and 2. And I get 6x minus 6y equals negative 12. Negative 6x plus 6y equals 12. What do you notice? Cancel, cancel, cancel. 0 equals 0, which means infinite solutions. Yes, which means that it's the same line graph twice. Now, could you have looked at that and seen, hey, they're the same? Yeah. So, if I divide this top one by 2, then I get x minus y equals negative 2. If I divide the bottom one by negative 3, I get x minus y equals negative 2. It's the same equation with the same answer, therefore it's infinite solutions. All right, the last one's kind of a pain because it doesn't work out to be a nice number. Let's isolate the y. We'll make Aubrey happy. So, subtract 6x. I'm going to plug this in. Oh my goodness, I did it again. I'm going to plug it in for y. So 2x minus 4 times what y equals, which is 14 minus 6x, equals negative 10. Now, what happens if I were to plug this? So if I were to take that 14 minus 6x, and I were to plug it in here instead of the top equation, what happens when you substitute an equation back into itself? Right, you're going to get infinite solutions. You're asking, where does a line touch itself? Everywhere. So you end up with infinite solutions. So 2x minus 56 plus 24y equals negative 10. 2x and 24x, is that an x or y? It's an x. So 26x equals 46. So this is going to be a decimal. What is 46 over 26? 1.76. I'm good. So x equals 1.76. Now the nice thing about substitution is if you plug it back into the substituted equation, then the y is already isolated. So if I plug this in here, I don't need to move anything. I just need to type in 14 minus 6 times 1.76. That's going to be 3.4. 3.4. I do. 3.4? Oh, 14 minus 6 times 1.76. 3.44. So that's everything you need to do the substitution and the elimination worksheet. And we are going to move on to more difficult substitutions and eliminations, but we're going to do something else first. This.